Hello, my name is Daniel Peluso, and I've been a modeler since 2019 when I was a high school physics teacher and attended the first ever AMTA modeling astronomy workshop. Since then, I started a PhD in astrophysics and astronomy education with the University of Southern Queensland, and also work as an education associate for the SETI Institute. I live in the Bay Area, California. As a part of my PhD work, I've been working to incorporate modeling instruction astronomy into citizen science efforts for education, specifically to study exoplanets. So what are exoplanets? Well, these are just planets around other stars. And to date, we have over 5,000 confirmed exoplanets, most of them being found through what's called the transit method. The transit method is when we take a telescope and we look at a star and we look for its change in brightness over time, as you can see here in the animation. And if we see a change in brightness over time, that could mean that there's a planet orbiting around that. That data gives us what's called a transit light curve, which you can see here, which is really important for exoplanet transit science. Transits are important because it's a proven method, sensitive to all the different types of exoplanets out there to give us a diversity of worlds. The data can give us the size of the planet, its orbital period, so how long it takes to orbit its star, and its distance to the star. And when we combine the transit data with additional observational methods, it can tell us more of the story of the planet, such as its mass and atmospheric composition. One of the space telescopes out there that's gathering a lot of data on exoplanets using the transit method is called the Transiting Exoplanet Survey Satellite, or TESS. It may actually find 10,000 new transiting exoplanets through its lifetime. However, there's only 200 of them confirmed so far. So there's this growing catalog of thousands of unconfirmed exoplanet candidates from TESS and other space telescopes and ground-based observatories. And citizen astronomers and small telescopes can detect them, so they can help confirm these exoplanets. But generally, they have these advanced technical setups. I'm very honored to be working with the SETI Institute and Unistellar, where we're working with this telescope that is really easy to use. It's a smart telescope, a smart digital telescope that fits in a backpack and is completely operated with a smartphone application. It's very easy to do an exoplanet observation with this. You just open up the app, press a couple buttons, click on a couple links, and everything autofills, and the telescope pretty much does all the work for you. This is an example of an exoplanet transit light curve that was actually inspired from modelers that created a GWiz astronomy group during the COVID-19 pandemic. And this included high school students from around the world that met on Zoom. They wanted to get a transit of the exoplanet HD 189733b. So we had the Unistellar network observe it for them, and this is what we got for them. So these students were able to get that transit light curve and learn about exoplanet science through the Unistellar network. What is citizen science, and how and why should it be included in education? Well, citizen science is just connecting professional scientists with average citizens. Anyone can collect the data, they can analyze it. There's even collaboration possibilities to publish. Some refer to it as crowdsourced research. Citizen science in the classroom has been shown through research that when you involve students in citizen science specific project-based learning activities, can actually increase their motivation and engagement. Think about that. If you're involved in something real, something that has some tangible results in the real world, that's probably going to be more motivating and engaging than just learning out of a book. It's also been shown to work well with female and male students from various racial, ethnic, underserved, and urban environments. Now, in citizen science astronomy, there is a difference between getting pretty images and doing science, and how we would like our science education to work in the classroom. We want to encourage the adoption of inquiry-based science teaching practices, such as the Next Generation Science Standards, or NGSS. Learning science should involve claim, evidence, and reasoning. I'd add to that wonder. We want to quench our curiosity and creativity too. However, getting data is hard in astronomy, and the universe is our lab, so we need a telescope that can actually collect the data. So how can we get this data? Well, there's these great initiatives such as NASA Exoplanet Watch, the NOIR Lab, their Teen Astronomy Cafe, AAVSO, and others mentioned on the screen here. I'm using the Unistellar network, where we're able to help fill that gap as well. And this is actually resulting in publishable work that involves K through 12 teachers and students. Modeling instruction astronomy. Why are models important in science? Well, it's kind of what we do in science is create models and continue to refine them. And modeling instruction has been shown to be one of the most effective ways to learn science. It's inquiry-based, and it's a teaching method where students learn by doing. Modeling instruction astronomy is learning astronomy by using real astronomical data, techniques, and skills, and building models with that data. A couple examples from some of our previous modeling instruction workshops on the screen. This is an example from the last modeling instruction astronomy with exoplanets workshop that was held in early 2022, where we used astronomical image files called FITS files in order to track the position versus time of an asteroid and create motion maps for an asteroid. We also, of course, since the modeling instruction astronomy with exoplanets, looked at exoplanet data and learned how to analyze exoplanet data. If you'd like to learn more about how you could incorporate this in your class, and it doesn't have to be astronomy, it can be a physics class or your general physical science class too, then please check out the AMTA course, Astronomy Modeling with Exoplanets. There's also free publicly available resources available online from the SETI Institute and from Global Hands-On Universe, such as an Exoplanets Lab, and on handsonuniverse.org, there's lots of resources that are available to connect you with real astronomical data. So please check those out. Thank you again for checking out this video. And if you have any questions or would like to learn more, please let us know. Have a great day. Take care. Bye.